Good morning, children. How are you all? Okay, welcome to Sanvi Learning Services. So today we are going to discuss about linear equations in one variable. Second chapter, the name of the chapter is linear equations in one variable. Okay, and the aim of the topic is knowing about linear equations and solving exercise from 2.1 to 2.5 problems. Okay. So in previous class, we have discussed the exercise 2.5 problems. Okay. See, all of you, exercise 2.5. So first bit is completed, isn't it? So I have given some homework from exercise 2.5 first bit problems. Have you all done homework? Yes, very good. How many of you have done homework? Once show your thumb. Okay, good children. Very good. So today we are going to discuss the remaining part of exercise 2.5. So see, exercise 2.5, first bit is completed. Now the second bit. From second bit, word problems are given. So let us see what is given word problems. See the second bit word problem. What number is that of which the third part exceeds the fifth part by 4? Okay. Asking here what number? The number is asking here. Okay. So the information is given about the number. That number which the third part exceeds the fifth part by 4. It means here mention the number. Okay. Number is mentioned here. So again, he is mentioned third part of the number. Okay. He is mentioned third part of the number and also fifth part of the number. And one more word, exceeds. Okay. Exceeds means increasing. Okay. So the question is given, what number is that of which the third part exceeds the fifth part by 4? Okay, children. So let us see how to solve this problem. Exercise 2.5. Exercise 2.5, second bit problem. Okay. So he is asking about the number, but that number we don't know. Okay. So first of all, take that number. Let the number be x. Let the number be. Let the number be x. Why? Because we don't know that number, right? So that number we are taking as x. And what is given again? Third part of the number. Third part of the number. Third part of the number means this number we have taken as x. Third part means x by 3. Right. Third part means the number we have taken x. Third part of the number means x by 3. And again, what is given fifth part of the number? Fifth part of the number. fifth part of the number. It means x by 5. Third part means x by 3. Fifth part means x by 5. Okay. Next. By the problem, some information is given about the number, third part of the number and fifth part of the number. So let us see what information is given. So what is given information? The third part exceeds. The third part of the number exceeds. Third part of the number exceeds the fifth part by 4. So this is the given information, right? The third part of the number exceeds the fifth part by 4, right? So third part of the number. So what is third part of the number? X by 3, no? So therefore, third part of the number means x by 3 is equal to fifth part of the number. What is fifth part of the number? X by 5. Okay, x by 5. And he said that here exceeding. Exceeding means increasing. Increasing means plus only now. Right? So exceeds means increasing. So increasing. How much increasing? 4. Okay? It means plus 4. Increasing means plus symbol. Right? So third part of the number is exceeds the fifth part of the number by 4. It means x by 3 is equal to x by 5 plus 4. So have you all understood this step? Right? So third part of the number means x by 3. What is saying about this third part of the number? Exceeds fifth part of the number by 4. Fifth part of the number is x by 5. Exceeds means increasing. Increasing means plus. How much increasing? 4. So plus 4. Okay, children. So that number we have to find out. That number we have taken as x, no? So all the x terms you send left side. Why? Because we have to find here x value. So here one number x by 3 is there. And this plus x by 5 send this side. It become minus x by 5 is equal to, here what number will be? 4. So we all know that if there is a fraction, to simplify that we have to take LCM, right? So here take the LCM of 3 and 5 to simplify it. So we all know that the LCM of 3 and 5 is 15. Why? Because as these two numbers 3 and 5, they are prime numbers. Their product only their LCM. Okay. So 3 into 5, 15. Now each and every number after taking LCM, each and every number we have to multiply by LCM. So take the first number, that is x by 3. And what is LCM? 15. So every number we have to multiply by LCM. So x by 3 into 15 minus, and what is the next number? X by 5 into 15. Like this, every number we have to multiply by LCM is equal to, right side how much is there? 4 is there. Right. Now simplify it. So when we simplify that, what we get here? 3 1s are 3, 3 5s are 15. And here also 5 1s are 5, 5 3s are 15. Right? So now what we get? Let us see. X into 5, 5x minus x into 3, 3x by 15 is equal to 4. Okay, children? Now simplify it. 5x minus 3x. 5 minus 3 is equal to no. The same way 5x minus 3x is equal to 2x by 15, that is equal to 4. Now we have to find x value. So one by one number you send the right side. First of all, this 15 send this side. Okay. So we all know that here 15 is dividing now. Here 15 is dividing. So when we send that side, it will multiply. So this side, the number 4 is there, right? The number 4 as it is. And when this 15 send this side, it is here it is dividing. When we send this side, it will multiply. So 4 into 15. 2x is equal to 15 for the 60. Again here 2 extra is there. So this 2 also send this side. Here 2x means 2 into x. It means here 2 is multiplying here. Okay. So when we send this side, it will divide. So x is equal to 60 by 2. 2 1s are 2. 2 3s are 6. 0 as it is. It means what x value we have got? 30. X value we have got here 30. Okay. But x means what we have taken? So x means we have taken the number. Okay. So therefore the required number. Therefore the required number. Therefore the required number. That number we have taken as x. How much we have got? 30. Okay. This is the answer, children. So have you all understood this problem? Okay, very good, children. Shall we go to next problem? Yes. Right. Let us see what is given the next problem. Okay, now see third problem. See the third problem here. Now see the third problem. It is given that the difference between two positive integers is 36 given. The difference between two positive integers, it is given 36. Okay. The quotient when one integer is divided by other is 4 given. Okay. The quotient when one integer is divided by other is 4. Find the integers. And here a small hint is given. If one number is x, then the other number is x minus 36 given. Okay. So here in the first statement it is given the difference between two positive integers is given 36. Okay. Two positive integers are there. According to the given hint, the two positive integers are, if the first integer is x, then the other integer is x minus 36. Okay. And the second statement is given the quotient when one integer is divided by the other is 4 is given. Find the integers. Right? So you use this given hint and we have to solve this problem. We have to find these two integers. Right? So let us see how to solve them. See, third question. According to given hint, according to given hint, so what is given in the hint? One number is x. If one number is x, then the other number, then the other number what is saying x minus 36, right? If one number is x, then other number is x minus 36, right? So now by the problem, so what is given in the problem? First, see the first statement. What is given first statement? The difference between the difference between two positive integers. The difference between two positive integers is equal to how much given? 36 given. The difference between two positive integers is given 36. So what are the two positive integers? One integer is x and the other integer is x minus 36. Okay. So one integer is x, the other integer is x minus 36. So difference means minus. Right. Difference means minus. That is equal to how much given? 36. Right. Now the difference between two positive integers is given 36, And again, what is given? The quotient when one integer is divided by other is 4 given. Okay. The quotient when one integer is divided by other, it is given that here x, this minus into x minus x, minus into minus plus 36, that is equal to 36. Okay. And again what he given? Again what he given? The quotient. The quotient when one integer is divided by other is 4. Okay. So what is the first integer? The first integer is x divided by the other integer is x minus 36. And what is the quotient we get? 4. Okay. So let us see how we get this x minus 36. You send this side. X is equal to 4 into here x minus 36 is dividing. When we send this side, it will multiply. X minus 36. So x is equal to multiply here 4 into x 4x minus 4 into 36 144. Okay. So now all x terms you send left side. This plus 4x send this side become minus 4x is equal. Here how much we get? Minus 144. Minus 144. So 1x minus 4x is equal to how much it is? Minus 3x is equal to minus 144. Again, we need x value. No, this minus 3 send this side. Here minus 3 is multiplying. When we send this side, we will divide. So minus 144 by minus 3. Here minus minus get cancelled. And 3 1s are 3. 3 4s are 12. 3 4s are 12. And again 2 will be here. 3 8s are 24. Okay. So what we have got x value? X is equal, we have got 48. Right. X is equal, we have got 48. And he asked that find the integers. Okay. Now what are the integers? Therefore, the two positive integers are, therefore, the two positive integers therefore the two positive integers, first one is x, no, 48. Okay. The two positive integers, what are they? X and x minus 36, according to given hint. So x value we have got 48 and x minus 36 means x value 48 minus 36. It means how much we get? 48 and 48 minus 36. How much? 48 and 12. Okay. So the two positive integers are x and 48 and 12. So this is the required answer what is asked here. Okay, children. Now let us see the fourth question. Okay, see the fourth question. What is given here? The numerator of a fraction is 4 less than the denominator. Okay. So what is given here? The numerator of a fraction is 4 less than the denominator. So here he is asking about fraction. Okay, he is saying about fraction. So what is saying about fraction? In the fraction we know numerator will be and denominator will be. So what is saying? The numerator of a fraction is 4 less than the denominator. Okay. If 1 is added to both its numerator and denominator, it becomes 1 by 2. Find the fraction. Okay. Two statements are given. So let us see how to do this problem. This problem you can do, children, it is very easy. So this problem is homework. You can do this problem. Okay. Now let us see the fifth question. According to given hint, you take the equations, right? Now see the fifth question. Find three consecutive numbers such that if they are divided by 10, 17 and 26 respectively, the sum of their quotients will be 10. And here one hint is given. Let the consecutive numbers x, x plus 1 and x plus 2. Okay. So when this consecutive numbers divided by 10, 17 and 26, the quotient how much we get? 10. So it means x is divided by 10. Next to x plus 1 is divided by 17 and x plus 3 is x plus 2 is divided by 26. So when these three consecutive numbers divided by 10, 17 and 26, the quotient we get here 10. So what is asking here? Find the three consecutive numbers, right? So let us see the problem. Fifth question. According to the given hint. According to the given hint. So what is given? Let three consecutive numbers. Let three consecutive numbers means serial numbers. Okay. So let the three consecutive numbers. What is given? One is x and one more is x plus 1 and the third one is x plus 2. Okay. And when we divide if they divided by if they are divided by 10, 17 and 26. If they are divided by 10, 17 and 26, the quotient, the sum of their quotients, the sum of their quotient, the sum of their quotients will be, how much given it is? 10 is given. Okay. It means first integer is divided by 10. First integer is x. It means x by 10. Sum means plus. And second integer x plus 1. It is divided by 17. Again sum means plus. And the third integer x plus 2. And it is divided by 26. So like this, if the first integer is divided by 10 and second integer is divided by 17 and the third integer is divided by 26, the sum of their quotient is equal to how much given? 10 given. So we have to find that three integers. Okay. So we all know that to find that three integers, so here fractions are there, we should take the LCM of the denominators. So what we get LCM of the denominators? The denominators are 10, 17 and 26 is there. So if we find LCM, here two table possible, no? 2 5s are 10, 17 not possible with two table, and here 2 13s are 26. Again here two table not possible. Okay, any table not possible here. Right. Now and here 5, 17 and 13 they are prime numbers. So we all know that product only their LCM. Okay. Now multiply them. 5 in 2 5s are 10. 10 into 17, 170. 170 into 13. 170 into 13, how much? 2000. LCM is 2210. Okay. The LCM is 2210. Right. $2,210. Now take each and every fraction and multiply by LCM. X by 10 into 2210 plus x plus 1 by 17 into 2210 plus x plus 2 by 26 into 2210. That is equal to how much is there? 10 is there. Okay. Right. Now simplify them. So when we simplify them, how much we get? Let us see. See here, 0, 0 cancel. And here, 17 ones are 17. 17 into 130. Right. And here, 26 ones are 26. 26, how many times it is possible? 85. 26, 85. Okay, children. So now, x into 221. It means what we get here? 221x we get. Okay. Plus, again here how much is there? 130 is there. 130 into x, 130x plus 130 into 1, 130 plus, and here also this x plus 2 multiplied by 85. X into 85, 85x plus 85 into 2. 85 to the 170 by 2210. That is equal to how much is there? 10 is there. Now all the x terms you calculate them. Here 221 is there. 221x plus 130x. 351x. 351x plus 85x. 221x plus 130x plus 85x. Total how much it is? 436x. 436x. And the constant numbers 130 plus 170. 130 plus 170 is equal to 300 plus 300 by 2210. That is equal to 10. Okay. So now we have to find x value, no? So one by one number send this side. This 2210 you send this side first. Here 436x plus 300 is equal to here it is dividing. When we send this side, we will multiply. So 2210. Now 436x plus 300 is equal to this, multiply them, 2210 into 10. 2,21,000 we get. Okay. Now this plus 300 send this side. 436x is equal to 2,02,100 plus 300 becomes minus 300. Okay. Now subtract it. How much we get? So 2,100 minus 300 is equal to how much we get here? 21,800 we get. Okay. Again this 436 send this side. So when we send this 436 this side, here 436 is multiplying. When we send this side, it will divide. So 21,800 by 436. Okay. So if we simplify this, 430 is 1 the, and this 436 50 the, right? So what x value we get here? X is equal to, we have got 50. Okay. So now find them. Therefore, what is asked here in the question? The question is asked here, the three consecutive positive integers. Therefore, the three consecutive, the three consecutive positive integers. So what are they? One is x, second one is x plus 1, and the third one is x plus 2. Okay. So first one is x. X means x value, how much we got? 50. And second one is x plus 1. It means 50 plus 1. And what is third integer? X plus 2. It means 50 plus 2. So what we get here? 50, 50 plus 1, 51, and 50 plus 2, 52. So these are the required three consecutive positive integers. Okay, children. So the same way, now let us see the sixth question. Okay, children, the time is up. So here again, some more problems are there. So these problems you can complete at home. Now the time is up. So these remaining all problems you complete at home. Okay, children. So this chapter is completed. In the next class, we will discuss the next chapter. Okay. Thank you, children. Thank you all.
Good morning, everyone. Welcome to Sanvi Learning Services. Yes, this is your physical science class. In the last class, we discussed synthetic fibers and plastics. That is our third chapter. So we completed that chapter. So in this class, we are going to discuss the next chapter, metals and non-metals. Okay, this is a very, very important chapter. So we'll start our session. Yes. So here, metals and non-metals. So in this, we are going to learn the main keywords, new words about metals and displacement reaction, lustrous, malleability, ductility, sonorous, non-metals, sonority, and good conductors of heat and electricity, and oxides of metals and non-metals. So these are the keywords we are going to discuss deeply in this chapter. So here, look at this slide. Early man used stones to make weapons, utensils, etc. So he needed weapons to protect himself from wild animals and so on. So this was the stone the early man used, okay, for different purposes. But there was some problem by using these stones. If they are stone, if some forces are applied, these stone was easily break. Okay, so by applying some force, this stone was breaks easily. So from the stone, they shifted another substance, that is wood. Okay, so they shifted from stone to wood. So they would make wood in different forms. But the problem with wood is it does not retain its sharpness. It also loses its sharpness. Okay, any force is applied to it. So here, one day, while looking for stones along a railbed, they found some small pieces. When they tried to break these small pieces, they found it did not break. Instead, it's only changed its shape. Okay, when they were trying to break this stone, it is not breaks. Instead, the shape of the stone is changed. So here, they were happy with this stone. So they make different utensils and weapons to protect themselves by wild animals and so on. So from that they are using this metal, that is a copper. Okay, copper metal. So copper metal does not break. So they are using this copper metal for different purposes. Right? So this is a Chalcolithic period. Okay, so that is a Chalcolithic period. So from the Greek word, chalco means copper. Okay, from the Greek word, chalco means copper, lithic means stone. Right? So first of all, they are used stone. From that, they shifted to copper. Right? So from stone age to they shifted copper age. After that, they used iron, so which is stronger than copper. Right? So they shifted from copper to iron. So this is the age of metals. Okay. So they used stone. After that, they used copper. After that, they shifted to iron. So iron is stronger than copper. So we know one more thing here. These are all the metals here. So now we know air around us. So in the air, we know the nitrogen and oxygen will be present. These two gases are more in atmosphere, right? The percentage of nitrogen is 78% and oxygen is 21%. Remaining all gases 2%. So the percentage of these gases is more in the atmosphere. So these are called non-metals. Okay, like these gases, nitrogen, oxygen, and chlorine, sulfur, phosphorus. So all these are non-metals. So these non-metals are also used for different purposes. Okay, so to know more about metals and non-metals, first of all, we should know the categorization of metals and non-metals. So here, this categorization of metals and non-metals. So look at this periodic table. We know in periodic table we have 118 elements. So how these 118 elements are arranged in this periodic table? So in this periodic table, we have S block, P block, D block, and F block. Right? So the left side part is a S block, right side part is a P block, and middle part is a D block, and bottom portion is a F block. So all the elements are arranged in all these 4 blocks. So here we have total 118 elements. So in this periodic table, we have elements, that means metals, non-metals, as well as metalloids. So now, so here in this we have total 18 groups and 7 periods. Okay, in this we have 18 groups and 7 periods. Right? So all the columns are 18 columns here and 7 rows we have. So here, the number starting from the S block 1. Here this is 2. So like that up to 18. So here the first group elements are also called as 1A group elements. Okay, so these are called 1A group elements, and second group are called 2A group elements. And next, this middle portion, that means D block, consists of all the B group elements. Okay, this is the third B, this is the fourth B, fifth B, and sixth B, seventh B, and eighth have consist of 3 groups here. This is the 8th group, and 1B, 2B. And next come to the P block. So in this P block, here, it starts from third A now. Again, it starts from A. So this is third A, fourth A, and 15th group is the 50A, 16th group is the 60A, 17th group 70A, 18th group 8th A. Okay, right. So here this bottom portion, F block elements. So the first row is the lanthanides and second row actinides. So here this group 1 elements or metals. Okay, 1A group elements or completely metals. We can also call them as alkali metals. The name of the 1A group elements, alkali metals. So in this group 1 we have lithium, sodium, potassium, rubidium, cesium, francium. Okay, lithium, sodium, potassium, rubidium, cesium, and francium. So here, the valency of these elements is 1. 1A group elements, valency is 1. So what is mean by valency? So valency is nothing but the element which is having the last shell electrons. For example, here, lithium is there in the 1A group element. The atomic number of lithium is 3. Okay, so when we write electronic configuration of this lithium, that is 1s2, 2s1. So here 2s1 is the last shell of this lithium element. Okay, so here in the last shell we have only 1 electron. So this last shell is known as valency. For all the elements in this group, lithium, sodium, potassium, rubidium, cesium, francium, for all the elements, the valency electrons are only 1. In the last shell, only 1 electron will be present. Okay, so here for 1A group elements, the valency is 1. Now here, we are calling all these elements are the metals and also alkali metals here. So for example, if these elements are reacts with water, they will form corresponding hydroxides. Okay, any one of the metal from this group reacts with water, it will form hydroxide. Okay, we can call it as a metal hydroxide because all these are metals only here. So that's why we can call it as a metal hydroxide. For example, you can see here sodium we are taking. Sodium reacts with water here. We are combining sodium with water. It will form sodium hydroxide and releases hydrogen gas. Okay, from the solution, it releases hydrogen gas. So remember that here, when the metals, alkali metals reacts with water, form corresponding hydroxide and releases hydrogen gas. Okay, not only sodium here, all the elements here in this group. So that's why here I have taken one more example. The M is a metal here and it is reacts with water, forms metal hydroxide, releases hydrogen gas. Okay, and all these metals are having only valency 1. For every element in this group having valency 1. In the last shell, only 1 electron will be present. Now, here the sodium metal is a very soft metal. We can cut the sodium metal with the help of knife. It looks like an eraser. Okay, the sodium metal looks like an eraser, completely looks like an eraser. We can cut that sodium metal with the help of knife. This is a very soft metal. So here these metal elements are soft, that means can be cut with a knife, and they are ionic in nature. Ionic in nature means they can transfer electrons. Okay, so these elements, the 1A group elements having the valency only 1. So they transfer 1 electron to the other element to stable with. noble gas elements. To understand that, we'll discuss about that later here. So remember that these 1A group elements are ionic in nature. Ionic nothing but transfer of electrons. So remember that these 1A group elements transfer only one electron, because here the valency of these elements is 1 only. That's why they transfer only one electron. So when these elements react with water, form corresponding hydroxide and releases hydrogen gas. And now look at here. This second year group elements, this group. So these second year group elements valency is 2. Okay, 2A group elements valency 2. So all the elements in the group consist same valency. So here for these all elements, the beryllium, magnesium, calcium, strontium, barium and radium have the valency 2. That means all the elements having the last shell electrons only 2. Here the magnesium, the atomic number 12. So here we can write electronic configuration 1s2, 2s2, 2p6, 3s2. Right. This is the magnesium electronic configuration. So you can observe this is the first shell, this is the second shell and this is the third shell. So here in this third shell is the last shell. So in this last shell we have only 2 electrons. That's why the magnesium have the valency 2. Beryllium, similarly beryllium also. The beryllium atomic number 4. So the electronic configuration 1s2, 2s2. So further there is no element, so there is no number. So we cannot write any number here. So this is the last shell here because atomic number 4 here. So 2 plus 2 here 4. So here's 2s2. Here this 2 is the valency shell. In this valency shell we have only 2 electrons. So we can say the valency of the beryllium 2. Similarly for calcium. Calcium atomic number 20. Right? So here 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Valency shell is 4 here. Last shell this is the. So in this last shell we have only 2 electrons. So calcium valency 2. So remember that in a group the first element valency is similar to all the atoms in the group. So here the 2A group elements valency 2 here. So now here these metals are also called as alkaline earth metals. Okay, 1A group elements are called alkali metals and these 2A group elements are called alkaline earth metals. So their 1A group elements are bases and these are also bases because these elements also when react with water forms corresponding hydroxides only. Okay, so here you can observe the example. We have taken calcium. So when calcium reacts with water, it will form calcium hydroxide and releases hydrogen gas. Okay, so here these are also forms corresponding hydroxides and releases hydrogen gas. So why we are calling these are the alkaline earth metals means, so these oxides occur in earth crust. So that's why we are calling these are the alkaline earth metals. So these are the harder than alkali metals. These are also soft only, but when compared to 1A group elements, these are somewhat hard. Okay, so 2A group elements are harder than alkali metals. And here these are also having ionic property. So these elements means 2A group elements also transfer the electrons. So how many electrons transfer from these 2A group elements means only 2 electrons, because the valency is 2 here. So these elements transfer 2 electrons from its valency shell to get stable. So all the elements in this group, when reacts with water, forms corresponding hydroxide and releases hydrogen gas. And next, here, come to the middle part here. This is the D block elements. So these D block elements are also completely metals. Okay, all these elements are also metals. These are the hardest metals. Okay, when compared to 1A group and 2A group, these metals are very hard. We can call these elements are also transition metals. So from third B group to 2B group, third B, fourth B, fifth B, sixth B, seventh B, and this is the 8, 9, 10 completely 8th group only, and 1B, 2B. So all these are called as transition metals. Okay. So here in this, the elements can show different valencies. Okay, in this the valency of the, that means here oxidation number will be changes. Now here you can observe this F block elements, the bottom portion of the elements. So here why these elements are separated from the periodic table? Why we are not included these elements in the main periodic table? So these elements are belongs to D block elements only. You can observe here lanthanides. Okay, from this third B group, lanthanides are started. Here next in this third B group, from the next row, 7th row, the actinides will be started. Okay, so here when we observe this in the three-dimensional case, we can observe this is also is in the D block, that means in the main periodic table. Okay, so here we are observing only two-dimensional in the textbooks. So here this F block is also from the D block only. From the third B group only we can write this. Right, so these are the F block elements. We can call these as the inner transition metals. All the F block elements are also metals. So we have S block elements as a metals, D block elements are also metals, and this F block elements are also metals. Okay, we can also call these as a inner transition metals. Now, come to here, this. Now come to P block. In this P block, we have third A group, fourth A group, fifth A, sixth A, seventh A, and eighth A group elements. So in this third A group elements, this is starts from boron, aluminium, gallium, indium, thallium, niobium. So here, the valency of these elements is 3. Okay, there is no special name for these elements. We can call it as a boron family. So the valency of these elements is 3 only. So when these elements are want to stable with 8 electrons in the valency shell, these elements loses 3 electrons from the valency shell. Okay, so all these elements from the third A group have the valency 3, and when these elements are want to stable with 8 electrons in the valency shell, these elements loses 3 electrons from the valency shell. So all these are also metals. Next come to the fourth A group. So fourth A group is a carbon family. So this is one of the special type of group here. So this carbon family, in this the valency is 4. The elements having all elements having valency 4. Carbon, silicon, germanium, tin, lead and flevovium. So all these are having valency 4. These elements neither losing the electrons nor gaining the electrons. Okay, these elements completely share the electrons. Just these elements share the electrons with other elements. Okay, these elements will not losing the electrons and gaining the electrons. Just sharing the electrons to stable with 8 electrons in the valency shell. Now, next groups we have 50A, 60A and 70A. So these elements are non-metals. Okay, the 50A, 60A and 70A are non-metals. So now, here these elements also have ionic property. So these elements will take the electrons, gaining the electrons to stable with 8 electrons in the valency shell. These elements will take the electrons. Here 50A group elements take 3 electrons and 60A group elements take 2 electrons and 70A group elements will take 1 electron. So we can write here the valency. Here the oxidation number -3 for 50A group elements, and for 60A group elements -2, and for 70A group elements -1. The oxidation number of 50A is -3, 60A -2, 70A -1, because all these elements take the electrons to stable with 8 electrons in the valency shell. Right? So for example, if you are taking 50A group element nitrogen. So nitrogen atomic number 7. So the electronic configuration 1s2, 2s2, 2p4. Sorry. So 1s2, 2s2, 2p3. This is the nitrogen valency. So the atomic number 7. Right? 2 plus 2, 4. 4 plus 3, 7. So here this is the electronic configuration of nitrogen. So observe the valency shell electrons here. So in the valency shell means here this is the valency shell. 2s2, 2p3 is the valency shell. That means last shell. So in this last shell, these atom, okay, this atom have 5 electrons. 2 plus 3, 5. So to stable with 8 electrons in the valency shell, it needs 3 more electrons. So what will happen here? This element will take 3 electrons from the other element. So when it takes 3 electrons from the other element, it's stable with 8 electrons in the valency shell. So similarly, the oxygen family, okay, this oxygen, sulfur, tellurium and polonium will take 2 electrons. And similarly, 70A group elements. fluorine, chlorine, bromine, iodine, and astatine will take 1 electron to stable with 8 electrons in the valency shell. So here, finally, we have 8A group elements. So 8A group elements are also called noble gases and zero group elements, and also inert gases. Okay, 8A group elements are also called noble gases, zero group elements, and inert gases. So these group elements having 8 electrons in the valency shell. These all the elements, helium, neon, argon, krypton, xenon, radon, and ogasin. So all these elements are stable with 8 electrons in the valency shell, except helium. Remaining all the elements from neon to ogasinum, all the elements stable with 8 electrons in the valency shell. So they are stable. So these elements do not take part in any chemical reaction. Okay, all these elements, neon, argon, krypton, xenon, radon, and ogasinum. So all these elements do not take part in any chemical reaction due to its stable electrons in the valency shell. These elements will not share the electrons, will not gain the electrons, will not lose the electrons, because already they have enough electrons in the valency shell. From the starting onwards, I am saying that here 1A group elements, 2A group elements, up to the 7th A group elements. All these elements are sharing the electrons, losing the electrons, gaining the electrons, sharing the electrons to get us 8 electrons in the valency shell. So here 1A group elements, 2A group elements, 3rd A, 4th A, 5th A, 6th A, and 7th A. So all these elements want to stable with 8 electrons in the valency shell like noble gases. So when an element is having 8 electrons in the valency shell, it is stable. So for that atom, no need to gain the electrons, no need to share the electrons, no need to lose the electrons. So that's why here, to stable with 8 electrons in the valency shell, here the remaining atoms except these noble gas elements, they maybe share the electrons, they maybe gain the electrons, they maybe lose the electrons. So here 1A group, 2A group, 3rd A, 4th A group elements, here up to 1A, 2A, 3A. These 3 group elements will lose the electrons. 1A group element loses 1 electron, 2A group elements loses 2 electrons, 3A group elements loses 3 electrons. To attain 8 electrons in the valency shell like noble gases elements. 4th A group elements just share the electrons to get 8 electrons in the valency shell. And 4th A, 5th A, 6th A, these group elements will gain the electrons. Okay, these elements takes the electrons to get 8 electrons in the valency shell like noble gases. So these noble gases, that means 8th A group elements, stable. They do not take part in any chemical reaction, will not absorb these elements in any chemical reaction. Okay. So this is a categorization of metals and non-metals in the periodic table. Okay, just I gave some introduction about metals and non-metals only. So we have a lot of information from this periodic table. So here, now we are going to discuss physical properties and chemical properties of this periodic table. So the physical properties of metals and non-metals. So here we know that metals and non-metals are very important for us. So here we have some physical properties of these metals and non-metals. So we can generally associate the physical properties with the most common metal. Okay, we must have seen gold. Okay, so here you can observe the coal, or we can also call it as a carbon. So this coal or carbon is a metalloid. This is not metal and non-metal. This is a metalloid. That means it shows the properties similar to the non-metal. Okay. So here we know 50A group elements, 60A and 70A group elements are non-metals. But this coal is a metalloid. It shows a property similar to the non-metal. So generally, we regard this coal as a non-metal. Right? So here, we can generally associate the properties, that means the physical properties of non-metal with coal. So here the physical state. So what is a physical state that we seen in metals? So here, metals are solids at a room temperature. Okay, so all the metals are solids at room temperature. The only metal, mercury. Okay, the only metal, mercury, this is a liquid. Okay, so this metal which is present in the thermometers, that is, this is in the liquid state. Okay, there is only one metal that in the liquid state, which is mercury. Rest all metals exist solid state in the room temperature. Okay, except this mercury, remaining all the metals exist as a solid state in the room temperature. So then what about the non-metals? So you can observe non-metals. Generally they are solids or gases. Okay, so these non-metals, you can observe this sulfur, oxygen gas. Okay, so generally they are solids or gases. Right, but the only metal, sorry, non-metal. Okay, only one non-metal, that is a bromine, which is a liquid at room temperature. The only non-metal, bromine, that is liquid at room temperature. And the mercury, this is the metal which is a liquid at room temperature. Okay, the metals are all solids at room temperature. One exceptional case, that is the mercury for metals, and for non-metals these are solids or gaseous state. Right? So here only bromine is a liquid state in the room temperature. Okay, remember these points. We'll discuss the remaining topic in the next class. Okay. Thank you all of you. Yes, dear students, we have completed already 2 chapters, right? Friction and synthetic fibers. Now we are in the 3rd chapter, metals and non-metals. So you have to complete your CW. So how you will write means here. So here, I'm not suggesting you to write from materials. So you have to write from your own by reading the textbooks. So those who are having textbooks, so in the backside of a lesson, you have improve your learning. If you don't know how to make one question, so you take the question from the backside of the lesson, right? There you have improve your learning. They will give some questions in that. So take one question and search the answer for that question in your textbook. You will get the answer definitely. So when you are reading the lesson, you will get more information. So when you are writing your own, so you can know how to read the textbook also. So you know how to make the answers for questions in different types. So I suggest you to write the answers from the textbook only. Okay, those who are not having the textbook, please watch the videos of our these classes. You have in your YouTube, we have a YouTube channel, no? So in that we have all the videos. So once go through with that videos and make the notes clearly and properly. Okay, when you prepare your notes by your own, it helps you a lot. Okay, thank you.
Dear students, please stay online. Sunday you have a free webinar on how to become a chartered accountant in future. What are the possibilities of like what is a growth prospect of becoming a chartered accountant? A trainer is going to give you a free webinar. Please look at the screen. This is going to occur on Sunday, 10 a.m. to 11 a.m., 1 hour. Okay. So if you are interested, it's better. It's a very good opportunity for you. Please register your name. Only the students who register name will be getting the link. Please register your name with the link that I am forwarding now. Using this link, you can register your name and attend the webinar session, which is going to be very useful to you when you complete your SSC. You can decide which course to select in Inter, and you can, it's a route to your career in future. Okay. So please note down this link, which I put in the chat box, and register yourself and don't miss this opportunity. Okay. Thank you.